Oh, hey everybody. It's going to be, I think I'll call it part 2. At least that's what I'm calling it now. On the Atwater Kent Model 708. Just a few quickies here, a couple of things. I have a rough diagram here, and it may not show good, of all the tubes, how I've laid it, or how it was laid out. This before I found a pictorial of where everything was. I've since kind of found a piece of paper that tells me a little bit more about where things are in these things. But anyway, the RF-AF chassis, which is a sub chassis on top of this thing, it's got 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5 tubes, all of which are number 58 tubes. So there's number 58, number 58, number 58, number 58, so there's 5. So first one is the first detector, then there's T9, second detector, which is number 58. I am so sorry. Start over. Tube number 1, that I call it. Tube number 1 is a number 58 tube. It's the first detector. And you have a transformer, IF transformer. Then the second tube, another number 58, called the first IF. And then transformer T10. Yeah, right. And then number 3 tube, another number 58. This is the second IF. Then T11. This right here is what I call tube number 4. It's going to be another, you guessed it, number 58. And then tube number 5, which is a number 58. Now, since then I have found, this is not going to show up good at all, but I found this online on the Philco radio forum. I think a guy had rebuilt one of these, and he actually had the card, the instruction card that come with it, and in it it describes every tube in here, gives you some placements of the tubes and a couple other things, little minor things here, but gives you frequency band switch. I found out what the frequency bands were and all this stuff. So I'm going to try to post all this stuff in a little bit better form in this video. Anyway, going back to my schematic, as I was mapping this thing out, trying to learn what made it tick, how it was organized, because I didn't have nothing but a schematic. Anyway, if you remember the last video, we had the band switch, which is represented here. The band switch, if you're looking under the bottom of the chassis with the knob to your left, you have the shaft going through here. The band switch is 3 wafers, 1 wafer, 2 wafer, 3 wafer, and you could look at it as split in half. So the rear wafer is going to be section A, section B, and then the middle upper part is going to be section E, and then below that is section F, and then to the left side it's going to be C section and D section. Now remember last time I told you about each section had a certain color wires that was common to each section. So starting from A is filled with white wires, B is going to be yellow wires, and then C is red wires, D is black wires, E is gray wires, and F is blue. And then of course the coils that's underneath the chassis, the oscillator coils are on the left hand side where the front of the radio is. It's going to be E1. Okay, E1, that's an oscillator coil. That's the oscillator and pre-selector coils. Okay, so it's going to be E1, E2, E3, E4. And then the antenna coils are going to be A1, A2, A3, and A4. Then of course the switch is going to be, if you're looking at the switch from the front, It's E4, E3, E2, E1, which correlates to, hang on, let me get my cheat sheet here. E1 is going to be your AM broadcast band. E3 is going to be your 1.5 to 4 megacycles. And then E2 is going to be your 4 megacycles to 10 megacycles. And then, or megahertz in today's speak. E1 is going to be your 9 to 20 megacycle switch. Which is pretty good information. Anyway, I mapped it all out. This gives me some reference to go to when I'm looking at the schematic. Now, going back to this, which I'm going to post a still picture on it on the video, it tells a lot about what's going on here, and I don't know, I couldn't find a picture of this per se. I had to snip it off another website, and the resolution kind of sucks. But this right here is one of the most important, and I'll post that on the video. Okay, so the next thing that I want to do is, I come home from work early. I don't really have much to do. I decide I want to come out to the shop. Now this right here, it looks like that canister that the old boy sniffed on District 9 and started turning into a shrimp. If y'all ever seen that movie, that's exactly what this looks like to me. Anyway, this is actually a very light. It has no electrolyte in it at all. This is one of the filter caps. Now, I don't remember the name of these. Maybe somebody could pitch in, but it has a screw here that you can screw this through a hole in the chassis, but in this case it had a clamp around it. This right here comes from the power supply attached to this filter capacitor, and that's how the connections was made. Now this thing is light as a feather, which means the electrolyte, which was a liquid type solution or a wet solution, has long since evaporated out of this. So I've pulled it out of the chassis, which it was quite nasty, and it looks like where this radio come from might have been a smoker. It's got some smoke looking stain. It don't smell like nicotine, but it sure looks like it. Anyway, I had to do a lot of scrubbing to get it down to this right here. Anyway, I plan on taking this apart and restuffing it. And I've got to looking at it, and there's it's completely sealed and mashed connections here, so you can't do anything with this. But here, the top, I believe what I'm going to do, that looks like it's furled up underneath. What I'm going to do is I'm going to take it over to my other shop, my mechanical shop, and I'm going to wrap this up in a vise with a towel, protect this. And I'm going to take my Dremel and very, very carefully, at least that's my plan, I'm going to try to cut this bottom of this tab off where this little top section will pop off. Then I should be able to scrape the insides out of this, replace the cap inside, and then I'll just simply glue this back on top. And it'll look like I've never been there. That's the plan. So anyway, I'm going to turn you loose for a second. I'm going to go over to the other shop, get set up, and then we'll come back. All right? See you there. Alright, here I am, guys, back in my other workshop, back in what they call the dirty shop. Let's get the zoom right on this thing. See how that works. Anyway, here's the filter can. Put it in patented vise right here. So, I'm going to tape this bad boy up on some of this here blue painter tape in an attempt to protect the case. Don't want to scar it if I can help it. I have never really stuffed caps before because I always just went the repairman route on it, you know. Which means to say I usually just cut the leads off the components, you know, twisted the leads like this right here and soldered them like that. But here lately I've been going completely. I've been going completely doing it the hard way, as some people would. And I kind of pride myself on that. Anyway, let's take this said Dremel. Let's see. Can y'all see? No, you can't. Hold on. Let's go for a ride. The only thing I don't like about working with it this way is I can't see my viewfinder. I think a lot of people will have a monitor attached to their camera so they can see better instead of this stupid little viewfinder. Alright, and I do wear a face shield. You're supposed to wear a breath mask too when you're using this because you don't want to get silicone poisoning in your lung. But I think this will be okay. Alright, here we go. Let's see if we can get this started. Got it in the vise, seems to be secure. Let's see what can happen. You know what? I'm making a lot of dust. Let me get a breath mask on. 468.5. My lungs are bad enough. I don't need them any worse. Hopefully you can understand me. I don't sound like Mickey Mouse. I'm going to put my little gloves on. This generates a lot of heat. Gotta be a better way. See, I got it to raise off there. I got that inner lip come off. So let's peel that for a minute. I'm about a quarter of the way through. Let's just continue to go around. Take your time. It ain't a race. So far, so good. Keep on trucking. About due for another wheel. Try to get my money's worth out of this. Let's change the wheel. Just break them off. I can get to the screw better. I don't want to take my glove off because I'm lazy. I don't want to do anything is easy, you know. Sometimes I'm too hard-headed for my own good. Here we go. Round 2. Okay, separating pretty good so far. Hope it don't be like a jack in the box, you know, and spring out and blow me up or something. We got a little bit more to go, not much. Try not to go so deep that I cut into the main circle. Just trying to see where I'm looking for where the metal starts separating. Well, I hope you guys can understand me when I'm in this this COVID-19 mask. Hear me through this drill. This dremel. All right, we have separation. Let me get rid of this face shield and this mask. Can you see? Oh man, I just realized what I did wrong. I am so sorry, guys. That was a totally boneheaded moment in my life right there. I've been doing the wrong side because I couldn't see what I was doing, that dumb little viewfinder. I am so sorry, guys. Anyway, I cut this lip around the top of this thing. I have it completely separated. Of course, it don't look like much now, but I'll clean it up. So let me see. Look at there. Where is it? There we go. I just popped the top off of it. Where's this stupid thing at? Everything's backwards. Look at there. I just popped the top off. Wow. Let's get back over to the shop. Let's have a close look at this. Alright guys, back in the main shop. I screwed up. When I had it in the vise, I saw this end right here. I don't know why. I have these lapses of stupidity. You couldn't even see what I was doing. I was on the other end. I had this down here in the focal point of the camera. I was over here working on this end. Oh my goodness. Sometimes I amaze myself. Anyway, I was able to cut the top off. So the top comes off. Boom. Let me get a light. Show you what this looks like inside. Look at there. There's your capacitor. It has lost every bit of its liquid. where it went, it drained out the bottom of the capacitor, I guess, went evaporated and all kinds of stuff. It's no longer with us. It has long since turned back in the atmosphere. But that's what it looks like inside this capacitor, y'all. Is that not cool? So all I got to do now is extract that, put the new capacitor in there, clean the top up, seal it back up, and you'll never know I was there. How about that? Okay, back again with you guys. Let's see if I can raise this up just a skosh. In the middle of this thing, let's see if I can enlighten it again. In the middle, there's a rod. I can't hold the flashlight, hold in the capacitor, and also point. So in the middle, excuse me, right in the middle there's a rod. You'll see a rod, a little round rod that the two capacitor sections are joined into. That is the goes all the way down. That's this. Okay. So what I'm going to do is I'm going to take two sections here, and I'm just going to go in there with the tool, I don't know, pair of needle nose or something, and get rid of all that and leave just that center portion. Now I haven't figured out quite yet how I'm going to do the center portion, but I'll cut you loose another second. But I guess we can go ahead and strip this out. Let's see what it feels like. It's kind of like a folded. It's kind of like a folded. If I can get it out intact, I'll show you. I'm just going down the center of it with my screwdriver. This is very thin aluminum. At least I'm going to call it aluminum. I'm probably wrong. I usually am every now and then, like 90% of the time. And I'm just going down it, pushing it, just kind of manhandling, I guess you could say. If that's a bad thing to say nowadays, oh well, move somewhere else. That's exactly what I'm doing, is I'm manhandling it. Or if you're a tough enough female, I guess you could say woman handling it, whatever. Whatever floats your boat. Okay, I think I've gotten it loose off of there. Let me get a pair of needle nose out of my crusty dusty work toolbox. See if we can get one of these out intact. Look at there. I'll tell you what, I wish I could get a little more light in this thing. A little section there is being a little hog about things. There it is. Got it. I think I can pull this rod out. That would make my life a little easier, but let's get the, excuse the scanner in the background. There you go. Completely hollowed out. I could stuff whatever I want to in there. I could even stuff one of them big old atom sprays in there if I wanted to. So this one's hollowed out. Here is the capacitor section right here. I hope this ain't PCBs. If it is, oh well. This little powder right here, probably what's left of whatever electrolyte was in there. And here's the other side. But all you old timers just looking at me like I'm stupid or whatever, I agree with you, but look at this. That's all it is. All this was And apparently this was just accordioned in there. Then they had a solution around it, and that's what acted as the capacitor. This ripples here, just increase the surface area. And if you want more capacitance, you have more ripple, or more material, more ripples. Anyway, that's that. And I don't know if I will make another part of this video or not, but I'm going to close it right here, clean up this mess right here, and think about this a little while. So it's either going to be part 3 or continuation of part 2. Anyway, talk to you later. Alright guys, just another piece of this little crazy little video. I didn't want it to extend too long. I pulled the center section here out of this. A couple of reasons why. This is aluminum or aluminum. I have a little problem. I'm still working on it. I'm still trying to figure it out, but I have a little problem here because this being aluminum, I can't just solder my other capacitors to this or this. I've got a little problem. It's not bad, but what I'm going to do, so I'm going to get rid of this. I should have just, if I didn't think about it, and I'll do this on the second one. This is my, prototype. You know how prototypes go. If you don't, you'll find out. Anyway, I'm going to pull this out. This rubber here is fairly deteriorated, so I don't think it's going to be shorted. It looks like it's got plenty of room, but I got to think about this. I got to think about this whole scenario here. I've got to think of how I'm going to do this. I may wind up cutting. I really don't know if I'm going to trust this old rotted rubber. I really don't. And I'm not saying for you guys to trust it at all. But I don't know, I may just cut this rubber out, okay? And see if I can straighten these swedges out right here. You see these? And I might go back and I might go back in there with it. I don't know yet. I'm working on this. It's running around in the back of my head. But I got to have a way to get the ground side of this capacitor, the replacement capacitor, which is going inside here. I got to figure out a way to get the ground side grounded, which means I'll get probably an axial lead capacitor. Hang on just a second. These things are fairly expensive. See, these are Sprague atoms, and I'm going to use a larger. A lot of people will use a smaller one, but since I have the room, I'm going to put, these things are about $15 to $18 depending on the value. However, they have a lot of capacity to them. They have a low ESR, equivalent series resistance. And for this situation, I think I'm going to use this capacitor, or type, not this one. This one's too big. This is an 80. I think all these capacitors are 20. I'm not sure. If I looked on the schematic, I'd know. But anyway, I'm not even sure. I'm going to put 450s in here because I don't know what the plate voltage is. I'd rather have a 450 in there. Anyway, I got to figure out what I'm going to do with this. I do think this is going to have to come out because it is really, I don't know if you can see that or not on this resolution of this camera, but it is really, really cracked. You can see it right there. I don't think I trust 400 volts in this. Last thing I want this thing to do is arc and cause a fire. I don't like fires. Anyway, that's my dilemma for now. So there you go. I will get back with you guys. Bye.